Hi again. So in this problem, let's see how we can solve trigonometric equation. And then let's give a general formula for all solution. Okay, not just one or two, for all of them. And then we want to list out 6 solutions. Okay, so let's see what we have. The first question will be sine of theta equals 1/2. So not so bad at all. We just need to look at the unit circle. Sine equals 1/2 would be right there. So the angle we're looking for is, actually, it should be a little down. So it should be like this. So the angle we're looking for is this one and that one. Okay, so it would be pi over 6 because pi over 3 would look like that. So pi over 6, and to find the other one, see how we have pi over 6 and pi over 6 right here. So the other one would be 5 pi over 6, where we get pi minus pi over 6. Because that is pi, subtract the angle pi over 6. So for sine, the periods would be 2 pi. So with that in mind, the answer for theta would be a set of all angle in the form of pi over 6 plus 2 k pi, where k is an integer. Okay, and similarly, theta can also be 5 pi over 6 plus 2 k pi, where k is an integer. So what happened when we add 2 pi is, say you're starting from this angle right here, and you add 2 pi, you're going back to that angle again, except that now it's a different name because you go 2 pi and you go one more rotation, you get back to that one again. So by adding 2 k pi, where k is an integer, we just keep going around the unit circle. Okay, so combine the two, we can just simply say, now that we know k is an integer, combine two solution set, you can just say theta equals pi over 6 plus 2 k pi, and also equals to 5 pi over 6 plus 2 k pi. Okay, so I hope that is not bad. How about we write it in terms of set notation so that it is consistent with the book. So theta equals theta such that theta equals to theta equals to. Okay, you don't need that. So that's the set of solution. Now let's move on to the second problem. Similarly, we have cosine of 2 theta equals negative 1/2. So what do we have? We want to look at the unit circle. Cosine is negative 1/2. So it's going to be somewhere right here. So this angle and this angle. So I have 2 pi over 3 and 4 pi over 3. Okay, so I'm not done because this would mean 2 theta. Remember, the angle is 2 theta. So 2 theta would be 2 pi over 3 plus 2 k pi, and 4 pi over 3 plus 2 k pi. Solving for theta. Divided by 2, divided by 2. And when you divide by 2, everything has to be divided by 2. Okay, not just the angle. 2k pi has to be divided by 2 also. And that would give us theta equals to pi over 3 plus k pi. Theta would be 2 pi over 3 plus k pi. Okay, so the solution set would be theta such that theta equals, just writing it again, I don't like how this solution is written, but it's what the book wants, so we're just gonna have to deal with it. Now, last problem on this type. I have tangent of theta equals negative square root of 3 over 3. And when you see tangent, simplify. This would be 1 over square root of 3. And remember how I say tangent is sine theta over cosine theta. So when you have this type of problem, you can always do negative 1/2 over root 3 over 2. We can put the numerator and denominator both over 2, and we'll get the same answer. The reason why we're doing this is that way we know what sine equals to and cosine equals to. Okay, so now let's look at the unit circle. You can pick either sine or cosine. Let's pick cosine equals to root 3 over 2 and see what we have, what we come up with. So sine is negative and cosine is positive, so it has to be on the fourth quadrant. And cosine is negative root 3 over 2, so it's going to be right here. The angle I want is this one, so this would be pi over 6, 2 pi minus pi over 6, and that would give me 11 pi over 6. Okay, so you can always write this because tangent, the period for tangent is actually pi. So then once we find out one angle, the other angle would be just exactly on the other side, which is 5 pi over 6. Okay, so the solution would be either pi over 6 or 5 pi over 6. I don't care. I'm sorry, 11 pi over 6. So you can say theta such that theta equals to 11 pi over 6 plus k pi, not 2k pi. Or you can say theta such that theta equals 5 pi over 6 plus k pi. Okay, and that's your answer. Now let's move on and see. Sometimes we cannot use the unit circle because we don't have a special angle. Say sine of theta just equals to pi over 4. How do we find the solution? So what we do is we're going to take the calculator and do sine inverse, both sides. And sine inverse and sine cancels out, give you theta equals sine inverse of 0.4, and that should give you 0.41. Okay, but we're not done. The problem with the calculator is it only gives you one number. And when you do this, make sure your calculator is in radian. Otherwise, you're going to get degree, and you don't want to get a degree out here. So once you have an answer, remember for sine, say your angle is right here, right? Let's do it a little smaller. Say your angle is this angle theta right here. Then your psi value would be the vertical one, and you have another angle going this way. Okay, so to find the other angle, which you need to find because your interval is 0 to 2 pi, you will see that this is another theta. So what happened is you can take 3.14 minus theta. 3.14 is just going to be pi. So the other theta is 3.14 minus 0.41, which would give you 2.73. And both of them would be your solution. Okay, so remember how I said above that for sine and cosine, often you have around two solutions, at least two solutions. Now, how about tangent? Tangent of theta equals to 5. And I can certainly use tangent inverse. Theta would be tangent inverse of 5 using the calculator. That would give me 1.37. And for tangent, it's a lot easier because period for tangent, t is pi. So to find the other solution, you just need to take whatever you get plus pi, which is 3.14, and you'll get the other one, 4.51, and you're done. Okay, so for tangent, it's so easy. Tangent, find the first one, add with pi, get the second one. Only for sine and cosine, you kind of need to look at this trig function, the unit circle. Okay, now how about this problem right here? 3 sine theta minus 2 equals 0. First, let's solve for sine. Would be 2/3. So theta using calculator would be sine inverse of 2/3, and that should give us 0.73. Again, say your angle is right here, then you have another one going right here because it gives you the same sine value. So what do? We're gonna take the other theta would be 3.14 minus that angle 0.73, and that should give you 2.41. And both of them would be the answer. Okay. Lastly, secant is -4. You don't have secant inverse, but we know secant is 1 over cosine. Theta is -4. Therefore, cosine theta is -1/4. So theta would be cosine inverse of -1/4, and that would give us 1.82. Okay, now same thing looking at the unit circle. Say your angle is right here. To have the same cosine is horizontal, you'll get that one right here. So if this is theta, that one would also be theta. How do we find the other one? We can simply take, because it's close to this angle, 2 pi right here. We take 2 pi minus 1.82, which is 3.14 minus 1.82, and that would give me 4.46. Okay, so my answer would be 1.82 and 4.46. Okay. Now lastly, we have one last type of trig function. I have solve each equation on the interval of 0 to 2 pi. See right here we have a not included 2 pi strictly inequality. So pay attention to the solution range. First of all, I have 2 cosine to the second plus cosine equals 0. And when we see the exponent to the second, you should think about quadratic equation. This is just quadratic equation in disguise. Okay, so you should let that one equals, say, x. So when we let x equal cosine theta, the function becomes 2x to the second plus x equals 0. Now we can very easily solve for this by factoring. So x would be 0 and x would be negative 1/2. But remember, we're not looking for x, we're looking for theta. So this would give us cosine theta equals 0 and cosine theta equals negative 1/2. Again, unit circle. Cosine equals 0 would be right here, pi over 2, 3 pi over 2. Cosine equals negative 1/2. Negative 1/2 be right here, 2 pi over 3, 4 pi over 3. And all of them would be your answer. So theta equals pi over 2 and 3 pi over 2. Theta equals 2 pi over 3 and 4 pi over 3. And that's going to be my answer. Okay, now moving on to the second problem. Similarly, tangent theta minus 1 multiplied by secant theta minus 1 equals 2, not theta, equals to 0. And this can simply give us tangent theta using multiplicity, multiplication of product identity, I believe that's what they call it. Secant theta equals minus 1 equals to 0. This would give us tangent theta equals 1, secant theta equals 1, and this means tangent theta equals 1, secant theta, I don't want secant, I want cosine. Cosine theta equals 1 as well. Okay, so let's look at tangent theta equals 1. We have sine over cosine, so this would mean sine theta equals cosine theta. And there's only 2 ways that it can happen. Right at pi over 4, square root of 2 over 2. And this would be 5 pi over 4. So theta would be pi over 4 and 5 pi over 4 for this. Secondly, let's look at cosine of theta equals 1. It can only be at this angle, which is 0 or 2 pi. But remember, we're not taking 2 pi, right? This is a very special one. We're not taking 2 pi. So the answer would be just 0. So overall, the solution will be theta equals pi over 4, 0, and 5 pi over 4. Okay, now lastly, oops, 2 more problems. Here I have sine squared theta plus 6 cosine of negative theta plus 1. So the first thing I think that I should do is distribute the 6 6 cosine of negative theta minus 6. Okay. Whenever you have different angle inside, you should be worried because when you have different angle, you cannot do anything. But luckily, using the identity of even and odd, identity, we know for cosine, it's just gonna be the same. Better, okay, better. But we still have two type of trig function, and everything should be in terms of one trig function only. So either sine or cosine, you need to pick one, right? We do have an identity with sine square of x. This is actually equals to 1 minus cosine square of theta equals 6 cosine theta minus 6. And how do I have this? Because I am looking at cosine square theta plus sine square theta equals 1. Remember, this is one of the identity. So now once we have everything in terms of one trig function, we can simplify, move everything to one side, and we'll have cosine square theta plus 6 cosine theta minus 7 equals to 0. Okay, and that would give us factor. Remember, we can let x equals cosine square theta, and that would becomes x squared plus 6x minus 7 equal to 0. This would give us equal to 0, and therefore x equals negative 7 or positive 1, which means cosine of theta equals negative 7, cosine of theta equals positive 1. This, you have no solution because the range of theta or range of cosine function is negative 1 to 1. So when you have 7, is something wrong. Something is definitely wrong. Okay. You know what? I know I was thinking and like this is something wrong with this because it doesn't go with my stretch work, and I can see right here that instead of a plus, I put out a minus. So that's what went wrong, but that's okay. Let's just change this into a minus. There we go. Everything should be fine. So moving on, cosine of theta equals 1. That would be right here. So theta would be just 0, not 2 pi, right? Not 2 pi because we cannot take 2 pi. So theta equals 0 is going to be my solution. Last problem. Tangent square of theta equals 3/2 secant theta. Okay, two trig function, not good. So what do we have? We have tangent square theta plus 1 is secant square theta. So we can bring this back into secant square theta minus 1 equals 3/2 secant theta, and this would be minus 3/2 secant theta minus 1 equals to 0, which is good because everything is in terms of secant now. We can let x equal to secant theta, and we have x squared minus 3/2 x minus 1 equal to 0, or just multiply everything by 2. 2x to the second minus 3x minus 2 equal to 0. factor, let's see, I'll get minus 2 right here and plus 1 right here. So that would give me x 2x plus 1 equal to 0, x minus 2 equal to 0, or 2x plus 1 equal to 0. Why am I writing this again? I don't know. X equals negative 1/2, x equals 2. Okay, but this would mean that because x is secant theta, so secant theta equals negative 1/2, secant theta equals 2, and that would be cosine theta equals negative 2, cosine theta equals 1/2. Okay, so again, this would be no solution. The reason is you cannot have cosine equals negative 2. The range is negative 1 to 1. So with cosine equals 1/2, where would cosine equals 1/2? Right there. So it should be pi over 3. We cannot take negative, so 2 pi minus pi over 3 going back, so 5 pi over 3. Therefore, my solution would be pi over 3 and 5 pi over 3. And that is it about trig function. There's a lot, I know, but please check it out and let me know if you have any question.